What is it? Not polynomial.
What we did last time.
What did we do last time?
I don't know.
Radicals. Radicals. That's a radical. Okay, how about something like this? Is this a polynomial?
Probably not. It doesn't have a square thing.
No, it doesn't need a square thingy, but this is a rational because x is in the bottom. Okay? So this is a rational. He is not a polynomial. How about this guy? Is this guy a polynomial? No, he's a what?
Not a polynomial.
Starts with an E?
Exponent.
Exponential, yeah. Exponential. Okay, what about this guy?
Something.
Log? Yeah. He's logarithmic. He's not exponential. Or he's not a polynomial either. Okay, so something that is just a normal equation, like a trinomial, or it could have something of the fourth power, that's a polynomial. These guys are not. Okay, so there's key points to a polynomial that helps us figure out what they look like. Okay, so this guy, he's the leading coefficient. The degree of a polynomial is always the highest power that shows up in the polynomial. So this guy would be the degree of the polynomial. Okay? And then this guy is the constant because he has no x or variable with him. Okay? The constant tells us where it's crossing on the y-axis. So the constant is actually the y-intercept. Okay, and then the leading coefficient, I didn't finish writing that. The leading coefficient and the degree tell us the behavior of what's happening in this graph. Okay, this is something we've talked about before, but we'll see if we remember any of it. Okay, so if we have odd degree and we have a negative number, so odd power, negative, and we'll say leading coefficient. Okay, so if we have an odd power and a negative leading coefficient, our picture will look something like this. Whoop, I lied. It's going to look something like this. Okay, down a ski slope. Okay, so that means if we remember our quadrants, this is 1, 2, 3, and 4. This means if you have an odd power and a negative leading coefficient, you're in quadrant 3 to quadrant 1. Okay? So if you have an odd power and a positive leading coefficient, okay, so that could be
There's my drawing.
okay, thank you. If we have an odd power and a positive leading coefficient, so say it was like 2x to the power of 3, then it would look like this, like up a ski slope. Okay, so we would be in quadrant 4 to quadrant 2. Does anybody remember doing this before?
Sure.
Okay, we had it all mapped out before. Okay, so if we had an even power, so what if we had an even power and a positive leading coefficient? I'm just going to put LC for leading coefficient so we don't have to write it every time. Even power and a positive leading coefficient. So that would look like something like if I had 2x to the 4. I have an even power and a positive leading coefficient. If we remember, I always make it look like a smiley face because even when you're positive, you're smiling. So that is quadrant, what is that? Quadrant 3 to quadrant example of a whole bunch of types of polynomial equations. So polynomial equations, if they have a 0 degree, that would mean they would look like this. Something like that, or sorry, y equals 4. That means they don't have an x in it, and they're just a constant straight line. So they would look like a straight line, okay? It goes through each different type. So if you have a degree 1, so that equation would look something like this. We recognize that as a line with slope because this is our y-intercept, this is our rise and run, okay? So a line like that will look like some sort of slope, okay? And the key to polynomials is the power, or the degree, tells you how many times they change directions. This was a constant one. And so this was like, what's that? A straight line, yeah. With slope though. Degree 1, yeah. So this one is a degree 3. He would change directions 3 times. So if you look in your textbook, they have one for a degree 3 that looks like this. Because if you count how many times you change directions, you're going once, twice, 3 times. It changes directions 3 times. The power determines how many times the graph changes direction. Okay? The degree also tells you how many times it could be touching the x-axis. So if you have a degree of 3, that means you could be crossing the x-axis 3 times.
Is it also, is it always across the x-axis if it changes direction?
No. So it doesn't have to be 3, but the maximum amount of x-intercepts would be 3. Okay, so in a lot of these questions, they'll say, how many possible x-intercepts are there? So if you had something that was, I could put another blank screen. Say I had this. Say I had this. The degree of this one is 5. So let's see. Okay, so if this is a degree of 5, then it's changing direction 5 times. And the possible x-intercepts would be 5. Okay, it doesn't mean there are 5 x-intercepts, but there could be a possibility of having 5 x-intercepts. And also, if I wrote these like this, this guy is the leading coefficient and the highest power. So we're referring to him. This guy isn't, he's just written first. It doesn't matter who's written first, it's who has the biggest power, and then he becomes the leading coefficient. Okay? So let's cruise to, where are we cruising? Examples. We kind of talked about these. This one says, what would be the degree and the leading coefficient of the polynomial functions? This guy is not a polynomial function because he has a root in it. This guy is an absolute value equation, so he's not a polynomial function either. Okay, so if we wanted to know the degree and the leading coefficient and the constant term, this one has a degree of 4, a leading coefficient of 3, and a constant. Does it have one? No. Constant of 0 we don't put none because it still has it, it's just 0. Okay, so this one has a degree of 3, a leading coefficient of 2, and a constant of -1. And remember, the constant means that's where it's crossing on the y-intercept. Okay, we're on example 2, page 110. So identifying the following characteristics. So we're giving these equations. Okay, we're given these equations, and we need to match them with the appropriate graphs. Okay, so you should be able to pick enough information out of an equation to identify it in a graph. Okay, so looking at A.
It changes direction 4 times.
It changes direction 4 times because of the degree. Okay, so that should help us pinpoint it on here. This guy is 1, 2, 3. This guy is 1, 2, 3, and 4. This guy is 1, 2, 3, 4, 5. And 1, coefficient and an even power. So he's frowning, right? He should be in quadrant, what is that? 4 to quadrant 1. So quadrant 4 to quadrant 1, who do we see that's frowning?
D.
D. Okay, so just based on those things, we can tell that the picture should be for D. Okay. Also, you can list the number of x-intercepts. That possible x-intercepts would be 4 for this one. Whether the graph has a max or min. Okay, the only ones that have a max or min are the even ones because they're the smiley face or the frowny face. This guy would have a max. This guy would have a minimum. The odd number powers do not have a max or min. Okay, so in this case, do we have a max on D?
I think
Yes, we would have a maximum value. Okay, and then it says, what is the y-intercept? So we know the y-intercept, if I scratch him off,
4.
he's -4 because he's that value. Okay, and so we've picked all the things out that we needed to pick out. You could do that for B also. So if we're looking at B, he's positive, but he's odd. Positive and odd is you're heading up the ski slope. Okay, so positive and odd, you should be in quadrant 4 and 2. Okay, so who's in quadrant 4 to 2? This guy?
Yeah.
Okay, does he change direction 3 times? 1, 2, 3?
Yeah.
Okay. And his y-intercept should be 3, so he's probably crossing at 3. So B would be matching with